So menu 7 number 2 is fine if we know the mean, the standard deviation, and we want to find a probability. If, however, we're told the probability and we've got to go back and find a value, we need to use menu 7 and number 3, inverse normal. Now, inverse normal only works with less than. So the calculator is programmed that it knows that for any given probability, if that's the probability, then it can find this value of A. It can't do the upper part. So for the first one, it's straightforward. So we know the probability is 0.75. We know the standard deviation is 3 and the mean is 20. So the calculator will tell us straight away that A is 22.0. If we have a situation where it gives us greater than, we have to convert this to being less than, which is just 1 minus that answer. Then the calculator can do it for us. So if the area is 0.6, it's 20.8. If it's between two values, then we've got to convert it into two less than. So this is all of less than A. Let's think about the diagram. So I'm taking all of less than A, and then I'm going to subtract the bit that's less than 16. Because the calculator can find this value quite easily. And then I can do my inverse normal. So menu 7 number 2, because I want to find the probability it's less than 16. So that's from negative 1,000 up to 16. Sigma's 3, mu's 20. Calculator tells me that's 0.0912. Store that. Now I can go to inverse normal, menu 7, inverse normal, and the area is 0.3 plus that probability I've just worked out. And A is therefore 19.2. I could check that, menu 7 normal, if I'm going from 16 to 19.2, is the probability 0.3? Pretty much. So, just one in context. So 60% are less than D. So the probability that D is less than X centimetres is 0.6. It's a less than, so it's already set up for using inverse normal on the calculator. The area is 0.6. Standard deviation is 1.5. And the mean was 20. So X is 20.4. The interquartile range well, the probability you're less than the lower quartile is 0.25 because the quartile's the quarter point, so the probability will be 1/4. So the lower quartile will be whereas the upper quartile, 75%, 3/4 of the data is below that. And so the interquartile range It's the upper quartile subtract the lower quartile.